All right, welcome everyone. Today is Wednesday, the 6th of March, 2024, and this is the Cluster API Karpenter Feature Group meeting. We are a sub-project of Kubernetes SIGs, and as such, we follow their meeting guidelines, which basically means please treat everyone as you would expect to be treated, and please raise your hand if you'd like to speak, and I'll call on you. Although there's only 4 of us, so it's not that big a deal. I invite everyone to, put their name on the agenda in the attendees list if they feel like it. There's the link. You just need an account on HackMD to be able to write to that, but they're pretty easy to get. I had a topic that I wanted to talk about because I'm getting deeper and deeper into kind of the design of what I think will be the proof of concept that we're working on, or I'm getting into the implementation actually. And I've started to set up a repo, and I spent a lot of time over the weekend setting up like a docs site for it. And the reason for that is what I'm trying to do is, as I'm writing code, I'm trying to like record some of the design decisions that we're talking about and everything, so that we have kind of like some living documentation that goes with the project. And I can probably show that, maybe towards the end of the meeting if people are curious to see it. But it's nothing too big right now. It's just I'm trying to get things in place so that we can have a repo together. But as part of this, and I guess let me copy this into the agenda here. As part of this, I'm starting to get into making some decisions now about how we do the split brain between the management cluster and potential workload clusters, because Karpenter operates in a similar way that the cluster autoscaler does, in that, it needs to be able to see the node objects and the pods, and it also needs to be able to see its node claims and node pool objects and the node classes that are made. So this creates kind of like a question, which I thought was interesting, which is, where do we want to see the Karpenter objects being expressed? And my initial thought is like, okay, we probably, like cluster autoscaler, I imagine our advice is going to be, you probably want to run Karpenter where your CAPI resources are, because it's going to need to look at those CAPI resources. But of course, you don't have to do that. But I think probably the recommended way to run it would be to run it in like the management cluster or something, so that it can see the CAPI resources, and then you can give it a workload kube config so that it can see the pods and the nodes in the workload cluster. But then I started to think about it, and it was like, okay, well, it seems like maybe we would just want the node claims and node pools and all that other stuff to exist in the management cluster, right? But then only the administrator who has access to the management cluster can change the way Karpenter is configured in those situations. So if there was a situation where you had a kind of like a management cluster and mini workload clusters, and you wanted the owners of those workload clusters to be able to manage their own Karpenters, then maybe you would want, the node pool objects to be somewhere different. And also, there's kind of an interesting notion of like, if the node claim objects were being created in the workload cluster, in the compute cluster, and the controller was then creating machine objects in the management cluster, that might create some sort of dissonance or like just a behavioral pattern that would be, I don't know, difficult to debug, or maybe wouldn't quite be what people want. So anyway, so that's kind of like what I've been thinking about as I've been looking at some of this stuff. And I wanted to see if people here had thoughts about this or opinions. Like, should we just keep all the Karpenter objects in the same place as the CAPI objects? Should we have them split? Like, what do people think? Yeah, Jack, please.
Do node claims and basically things that we're classifying as Karpenter objects, are those the life cycle of those things is beyond just a particular like in-memory reconciliation? So a node claim is actually going to be an object that persists somewhere?
As I understand it, yeah, like a node claim is created when Karpenter says, I would like you to make this node for me. And then it's the responsibility of the provider to like reconcile that node claim. And as I understand it, the node claim stays in the system until the instance is like released or whatever. And I think there's even a status condition where you can communicate kind of what's happening with that instance and everything. So I think those node
I see.
claims.
So it has owner-like properties then, in
I
terms
think
of
so,
the
yeah.
underlying infra, the underlying actual nodes.
That's my understanding.
Cool. I'll try to throw some ideas out in terms of answering your question, Mike, about where should these things be. In cluster autoscaler, the pattern that I have observed in terms of, because as you mentioned, there's really going to be one in this case Karpenter, like there's one cluster autoscaler per workload cluster.
I would guess,
so typically those are,
yeah, it's gonna be the same with Karpenter.
yeah, typically those are namespaced. So in the cluster autoscaler situation, there aren't the operational footprint of cluster autoscaler is really just the runtime. And typically, like if I were to install that on a management cluster with 100 workload clusters, each of which was cluster autoscaler enabled, then there would be 100 cluster autoscaler runtimes running on that management cluster, each with a cluster specific namespace, a workload cluster specific namespace. So if I mean, I'm using a big number. I'm not sure if anybody's actually managing 100 clusters with 100 discrete cluster autoscaler CAPI runtimes, but that would be the pattern. That's how it would scale.
I've seen that done and help manage something with 150. That's
Cool.
the largest scale that I've done.
Thank you for sharing, Scott. That's great.
Yeah.
And cluster autoscaler held up?
Cluster autoscaler definitely held up. It just meant that I needed a few extra nodes in my management cluster than initially.
Yeah, cool. Excuse me. So yeah, if we extrapolate that pattern to Karpenter, it's similar with the addition that there are now part of Karpenter's state machine includes the presence of CRDs that are continually maintained. So you're going to probably, I would imagine, have a Karpenter runtime with a workload cluster specific namespace for each workload cluster. And then all of its CRDs are also going to be namespaced to that specific cluster. That's how that would work. So similar scaling. I don't think that the big O really changes much there, but in practice, from a human being's perspective, having those additional CRDs present on the management cluster is going to be something we want to account for. So to me, that's the downside of doing the sort of best practice from a plumbing point of view, having each individual Karpenter runtime and all that stuff have to call back to the management cluster with a privileged connection is non-ideal.
Yeah, I think so. Really, when I was thinking about these things, I was like, well, there's like some interesting patterns that arise where like, the workload cluster is containing information about like what Karpenter is doing, and then somehow that's getting ferried back to the management cluster and things. But it's like, I don't know, it just seems like a debugging nightmare, It's like, like Karpenter's doing something. It's like, now I got to look in the workload cluster and now back to the management cluster. Now, it's like, I don't think that would make anybody's life easier. So, okay. So it sounds like maybe the way to proceed here is like, let's proceed with the assumption, or maybe the recommendation, that the way we prefer that someone would deploy Karpenter would be similar to the way we think they should deploy cluster autoscaler, meaning that you will have it on a management cluster and it will be namespaced with the CAPI resources that are associated with the cluster it is managing. I saw your hand.
I think there's one question on that, though, that we have to see, because I don't know from the Karpenter side. That's the way that I've always done it with cluster autoscaler and recommended doing it with cluster autoscaler with CAPI. But what we see by a lot of customers is that they actually install multiple clusters in a single namespace. And I don't know how Karpenter would deal with, if you had two Karpenters in a namespace, how it selects the node claims or the relevant CRs that it's managing with Cluster Autoscaler, it does it very easily based off of the machine deployment selectors and based off of the label selectors of CAPI. I don't know how it would do that with node claims. So we'd have to see, because that is a very common use case to have more than one cluster in a namespace on the management cluster. So we'd have to see that can work. And I'm not sure it can.
Yeah, that's a great point, Scott. Thank you for bringing that up. Jack, did you want to add something?
Yeah, I agree with Scott that I think that we can solve for that, although that's a kind of a gnarly operational nightmare. But I agree that I've seen a lot of folks wanting to do that. But in terms of what are we going to ship with in terms like having both options, we could just MVP the prototype to only support Karpenter running on the management cluster. And I would imagine it wouldn't be it wouldn't be hard to implement that in such a way where it's extendable. So in the future, we can accommodate a spike to enable support running locally on the workload cluster with some kube config context that is able to call back and actually operate against the CAPI resources. Just in terms of an MVP, that seems like a reasonable thing to exclude, first of all.
Yeah, I think that sounds good. So like I will probably, oh, Mike, I see you raise your hand. Please go ahead.
Oh, nothing. I was just gonna throw out there, I know, and this is just something that we probably just need to get over. My team has hesitancy to run everything through a management cluster. From like the cluster autoscaler or Karpenter, not for any one particular reason, but because the fear of all the eggs in one basket when it comes to autoscaling. But I did, I've mentioned that before, so I just wanted to call out here that I do think running it on the management cluster is a better approach to take, because it does kind of emulate that managed Karpenter feel that I know a lot of people have talked to me about of wanting, instead of having to run Karpenter on every single cluster.
Yeah, thanks, Mike. And I think like the important thing to note here too is that in the long term, we want to support the same options that we have for cluster autoscaler. So in the end, I would hope that a user can run Karpenter with the same kind of considerations as cluster autoscaler. Like, you'll have both kube configs and you can choose where you want to put it based on, whatever works for your, for your environment. Scott, oh, you right. Okay.
No, I think the one other, kind of tricky thing we've seen I think one of the main benefits of running it in the management cluster is that it also solves for the issue that came up a few weeks ago in the meeting, where someone had mentioned that one of the issues with the Karpenter they were having is that Karpenter should not run on node pools that are managed by Karpenter. By having it run in the management cluster, I solved that issue. Right? The second you run it on the workload cluster, you're going to start, okay, I'm going to have a machine deployment, but then I'm also going to have Karpenter doing its things. And then you start with not everything is managed the same way. If you do it in the management cluster, we can solve that issue by the entire workload of a cluster can be managed by Karpenter, and you never have that issue of running something on the thing that it's managing. So you do get that element of a benefit there. Use Cluster Autoscaler for your management cluster, and then use Karpenter for all of your workload clusters. It's just deployed on the management cluster and you don't have an issue.
Jack, please.
Yeah, great point. And that's definitely a problem that folks run into with Cluster Autoscaler as well. But just wanted to add a super annoying note that even though this is true, we want to make sure we design the runtime so that it can be evicted and restart and idempotently make forward progress on another node. I don't think that would be a problem for us, but
I think we're going that way because like we're going to be relying on etcd as like our data store basically. So I don't think there'll be any state. It'll be much like cluster autoscaler. Like it will learn its state once you restart it, and it looks at the cluster again, and it hopefully will be able to figure itself out, from there.
I think the presence of the node claims is definitely part of the state machine. So I would imagine that it's going to continually operate against the declarative config in the node claim to make sure
Right.
that it's reconciled, right?
Right. And but what I imagine it would do, and I haven't looked at this loop specifically, is like it's going to come up, it's going to see a node claim, and I think theoretically what should be happening on the provider side is that our provider should be acting on the conditions in that node claim. So like if we see that the node claim is in like a fresh state or whatever, then it's like, okay, we better start making a machine. But if we see that like it already has the condition that like a machine was created or something, or that it's been started, then we know that we need to find the machine that's associated with that node claim or something. I mean, presumably it'll have a reference on it. I think that's the way we're dealing with it now, but yeah, it's a good point though. Well, this has been pretty productive. So like I'm gonna continue in the direction I've been going, and just for folks who maybe haven't kept up or haven't seen the recordings, I'm in the process now of like converting the Quack provider into like the first version of what might be our provider. And I think the reason I'm taking that approach is because the Quack provider is like very easy to just kind of understand. And what I'm going to try to do is, and I don't know if I'll be able to do this before we present for the cluster API group, because I'd like to share our design like maybe in the next couple of weeks so we don't get too far in case people come up with stuff. But like my hope is I'd like to get Karpenter running in such a way that I can have the KubeMark provider be like a test bed for me. And what I'm hoping to do then is like use the simplicity of the Quack provider to kind of see if I can get it doing what we think it should do, which is like we'll have infrastructure machine templates with a couple different names. And then in the node pool, you would use like some sort of you would use regex or searching on those names to be able to say, okay, these are the type of nodes you should look at when you see a pod of this type coming in. And then ideally what we'll see on the back end is we'll have like I'll make like a kube or a cluster API node class, right? And so ideally what we'll see on the back end then is we'll see a node claim appear. It will have the name of an infrastructure template, kind of embedded in it, or perhaps a reference. I have to look back at my notes to see how I'm doing that. And then the provider will look at that. It will take the infrastructure template that you've given it, which will be like an infrastructure KubeMark machine template. It will take a bootstrap provider config that, will be set up from I think through the node claim as well, or through the instance class. And then those will get put together to make a machine basically and satisfy the node claim. So what I'm really trying to push for on the first version of this is just to see if we can get this pattern working where we have infrastructure machine templates in the system. Karpenter is able to make a node pool from those infrastructure templates and then can start producing node claims based off of it. And then our provider reacts to the node claims by creating machines. I've still got a hiccup to work through in the KubeMark provider in terms of these orphan machines coming online, but like I can see that they're being made and everything. So I have no reason to think that there's any problem with this. So that's kind of like where I'm at. And I'm going to try to document the architecture of this along the way so that hopefully we can have discussions about that as well. Scott, you had your hand up first, please.
I think one question that I don't know if we've thought about yet, but from my understanding from the node claims and the instance types in Karpenter, it's basically like the size of machines that you want in AWS, Azure, anything like that. An infrastructure machine template in CAPI is way more specific and lots of times is tied to a very specific availability zone or vSphere cluster or OpenStack cluster, and they're actually tied to a specific implementation. I'm not sure. Have we checked if Karpenter allows, like, can it make the selection of the infrastructure machine template based off of what AZ the, pod was trying to be scheduled in? I don't know.
So this is a really great point, Scott. And I think it's something that we're going to have to deal with as CAPI as we understand this integration more. So in the first approach to this, like you're absolutely right. Like Karpenter, especially like the AWS Karpenter, you're able to give it like recipes, right? So it knows what an M6i is, and it knows what an X large is, and it knows how to put these together to make something. And then the zonal information even comes in another way. currently in Cluster API, if I wanted to express two different machines in two different zones, right? Like I would have to make two different infrastructure machine templates to specify that. So we're kind of limited by some of that. And I think in the first version of this, it'll just be kind of a one-to-one type of thing where like, okay, if you ask for a node or if a pod is coming in and it's requesting a specific zonal like matching and none of the infrastructure templates provide that zonal matching, then like Karpenter's not going to be able to make that zone. But in the future, what I would love to see happen is maybe there's a way that we can come up with some way to label or annotate the infrastructure machine templates so that we could start to build a language that Karpenter could understand so that we wouldn't necessarily have to be so verbose with a lot of these things. And I think I'm not quite sure what shape that's going to take yet, but like I'd been thinking about this if we had an infrastructure machine template and you were somehow able to vary parameters on it, like if you were able to vary the region or something like that, or maybe if there was a way for us to collect a bunch of infrastructure machine templates and describe a field that could be mutated or something, that might be a way for us to tell Karpenter, it's like, okay, you've got this size machine and it can exist in all these different zones. Some of this, the way it's going to work internally is that Karpenter has like an instance types interface basically. So I think a lot of what's going to happen is in the beginning, the CAPI provider is going to be going through enumerating all these different instance types, and then it's going to give them back to Karpenter and just allow Karpenter to make decisions. And yeah, like what that might mean is that you might have like more infrastructure machine templates than you expect in your cluster because you need to express them for all the different options. And I think, we might want to consider like tooling to help make that easier for users or something, at least in the first versions of this until we figure out, what it might look like. So I realized that was a really long-winded answer. I hope that kind of makes sense.
No, definitely. I think down the road, almost like the cluster class approach may end up being needed for an infrastructure machine template, like an infrastructure machine template class, where you could then kind of set that and where it could auto generate the infrastructure machine templates based off of those, input parameters or patches as a much later step. But yeah, as the initial step, it makes sense to have a dozen, 2 dozen, whatever it is, infrastructure machine templates, at least to prove out the value here and that it works. And then tooling can always be built. You're on mute.
The user experience may not be great early on because there's a lot of verbosity to it, but I think, Scott, you're like reading my mind exactly where this is going. Like we maybe in the future with the help of the Cluster API community, we could build up this, this language for Karpenter and, potentially other tools to do this kind of stuff. So yeah, very cool. Jack, you got your hand up, please.
Yeah, in terms of what we're going to build first, do you feel like we will do the CAPI part first so that we can start manually tinkering with node claim outcomes? If we simply implemented the stuff we need to do in CAPI to recognize node claims and to do that machine template correlation to actually build machines, is that something we could do first of all to start banging on things in practice?
Yeah, like the way I'm looking at this right now is I'm building a controller within the Karpenter framework that sees the node claims and then attempts to make machine objects, right? So like when it sees a node claim coming in, that node claim will be able to be matched with an instance class, like a node class from Karpenter. The node class, the way I'm predicting it now, will have a couple references in it, right? It'll have a reference to the bootstrap provider and a reference to the infrastructure machine template that needs to be used. And so when the CAPI controller for Karpenter sees a node claim come in, it knows the bootstrap and it knows the infrastructure machine template, and it can use those together or it knows the concrete infrastructure machine template. It can use those to create a machine object from scratch and then put that into the system. And so that's
got it. So there's no CAPI changes needed. So
right. No, right.
We validated that over the last months, I guess.
Totally. Yeah, we've kind of
That's
gone
awesome.
through. Eventually, there will be CAPI changes that will be needed to make this better because, we have the scale from zero enhancement in Cluster API, and one of the contracts that's described in there, the opt-in contract, is that every provider could put their instance information into the infrastructure template, right? So like eventually the CAPI changes that we're going to want to see are going to be things like that, because that will make Karpenter work better, right?
So it's more going to be like a provider roadshow advocacy.
I think so.
Yeah.
Like, unfortunately, like there's ways. We do have an escape mechanism or an override hatch in the scale from zero stuff. Like we can use annotations. So like, I think what I'm going to try to do is build the Karpenter provider to be able to recognize those annotations so that if it turns out the providers are like not taking this up or something or whatever, there's still a way for users to make this work. They might have to add their own automation, or we might have to build some sort of extra operator that can go and annotate all these things or whatever. But like, there's at least an option for people to be able to use this, even if it requires some more work to get there. We're just about out of time, but I guess like I could throw up a quick. Oh, wait, actually, why did I stop sharing there? I was gonna say just by way of just like, just for funsies or whatever. And I've got like make files and containerized targets and stuff that I'm trying to build up for some of this stuff. But here's where we are so far. I've got the basic documentation page up. So like more to come in the future. And as soon as I get to the point where there's something here more than just a few readmes, I will open the PR to get it contributed to the SIGs, and then hopefully what I'd like to do is have like I would love to have like our POC as kind of the mainstay for the first part of the repo, just so we could say, okay, here's something, we can run it with KubeMark, you can see how it works, and then hopefully we could start doing all of our collaboration from there, and start to take off. So
super cool, Mike. You inspire me.
Thanks, Jack. Does anybody have any like comments, questions, things you wanted to talk about before in the last like 30 seconds? Okay, well, I guess I'll see you all at the meetings. For those who are going to KubeCon, safe travels, have fun and everything, and we'll meet back here in a couple weeks.
Sounds great. Thank you.